Are you Kubernetes or OpenShift cluster administrator who provides the restricted cluster access to the individual application teams who are part of different line of businesses? Or maybe perhaps you are a developer who develops a containerized cloud-native application using the Operator framework, and you want to ensure that your application follows the best practices for the workload isolation? Hi, my name is Piotr Godowski from IBM, and I will explain how both personas can be successful with their goals. Let's start digging a little bit more into the scenarios we'll be talking about today. We'll start with cluster administrator. It's Margaret, and she manages the large OpenShift clusters. By saying large, I mean large, which means it has tens, hundreds, or even more worker nodes. And her goal is to make sure that the cluster remains stable and secure while there are multiple different applications running by different line of business teams. Martha is in one of such teams. Whenever she wants to deploy an application, cluster administrator is provided a set of prerequisite tasks and then assigns a specific Kubernetes namespace to Martha so that she owns the namespace but doesn't have access to any other cluster resources. Application which Martha wants to deploy is developed by Chris. Chris understands that his application will be reviewed by cluster administrator before allowing anyone to deploy it into the shared cluster. One of the key aspects of running applications on multi-tenant clusters is to follow the principle of least privilege, which in Kubernetes operators world is that Kubernetes cluster roles shall be eliminated or reduced to absolute minimum for both operators and their operands. And Chris knows that, and in Operator Cluster Service Version, or CSV in short, is not adding any cluster roles required for his operator. This way, Chris ensures that his application can be safely deployed into isolated namespaces and would not request any access to the resources outside of such namespace. Based on this, Margaret, the cluster administrator, can easily review the operator's metadata included in cluster service version to understand exactly which permission is required by operator and operand once deployed. It's a good practice for application vendors to document the required permissions if any cluster permissions are required by the apps. It significantly helps in Margaret's job. Let's go back to Martha. She decided to deploy a test and development version of the same application into the same cluster, each of the application instances into different namespaces. Having said that, Martha deploys two operators at different versions into those namespaces and then configures each of them differently accordingly to her needs. How would such a scenario work with operators and OLM? One of the aspects of Operator framework is that operators are introducing their custom resource definitions. These are the extensions of Kubernetes APIs and are processed by operators' controller logic to either create or reconfigure their operands. Custom resource definition, which is the schema of the operator APIs, is global on the cluster. In the other words, it is a cluster scoped. Any application running on any namespace on the cluster could see that certain custom resource definition is registered on the cluster. It is critical that Chris follows semantic versioning, or SEMVer in short, which is a strict definition of versioning scheme communicating the changes included in the application releases. Chris must pay attention to his operator, including custom resource definition, to be both backwards and forwards compatible. And Chris is also running tests to check it before he ships a new version of his operator. This way, Martha can deploy into the same cluster both older and newer version of the same operator, sharing the same schema of custom resource definition on the cluster. Thank you for joining me for this quick overview of the workload isolation best practices for Operator Lifecycle Manager based applications.